All right, class. So today we are going to continue where we left off yesterday with simplifying roots. Okay. We did an example, but due to time, we didn't write out the steps. So I'm going to go ahead and write out the steps for you. We're going to do this together. When you have a radical square root, in order to simplify or reduce like you would a fraction, it's kind of like reducing a fraction is what we're actually doing. In order to simplify a root, the first thing you must do is draw a factor tree. So over here under steps, you're going to say number one, draw a factor tree. And guys, go ahead and let's write this now so we don't have nothing to do later. Remember, this is part of a project grade. So this is one of the easiest grades you can get in this class is with the notes. Okay. So we got to draw a factor tree first. And we're going to circle the prime numbers just like we did in the example. Circle prime numbers. So to recap, yesterday we drew a factor tree. We asked ourselves, what two numbers can be multiplied to give us 100? And we said 10 and 10. Now we already know our answer is going to be 10 anyway. But what I wanted to show you how to do is just to show you the process of how to do it when we don't know what the answer is, okay? So we break down 10 because 10 is a composite number. That means it has more than two factors. So we're going to multiply. We can multiply 2 times 5 to get 10. So we're going to use 2 times 5. And then we circle 2 and 5 because they're prime numbers. Remember, in a factor tree, you cannot use 1 for a factor tree. That's the only number you can't use in a factor tree is 1. Your second step, after you draw your factor tree and circle your prime numbers, you're going to rewrite all the prime numbers or those numbers that are in the circles under the radical sign, under this radical sign, okay, like we did here. But you're going to do it in order from least to greatest. Least to greatest. So put them in order from least to greatest under this radical sign. Why do you do that? Why do you want us to put it in order from least to greatest, Ms. Reyes? Because in the third step, you're going to circle pairs. You're going to circle numbers that have twins, okay, where there's two of the same number. All right, so you're going to circle all pairs. Why are we circling pairs, Ms. Reyes? Why are we circling pairs? Because this is a square root symbol. Square root meaning 2. So what you're really looking for is a number that can be multiplied times itself, because that's the whole definition of square root. Finding the square root of a number is finding one number that can be multiplied times itself to give you that number that's under the radical. So that's why we're looking for pairs. So you're going to circle your pairs. I'm going to use the and symbol. And what we do is take out one number for each pair, or for each. Okay? So for this pair of 2, I take out 1, 2. And for this pair of 5, I just take out 1, 5. All right? Any questions so far? Okay. I'm going to pause, give you a chance to write. I see a couple people still writing. All right, so in the last step, number 4, you're going to multiply numbers, take out numbers that you take out from under the radical. These numbers right here, you're going to multiply them together. Then you're going to also multiply the numbers that are under the radical. And I shorthand, I didn't write a complete sentence. I just shorthand this, okay? It's not a complete sentence. So, in other words, I took out one pair of 2, so I wrote 1, 2. I took out one pair of 5, so I wrote down 1, 5. And there's no other numbers under this radical. So it's nothing to multiply here. So I didn't, nothing's left. But here, the numbers that I take out, I multiply these together and I get 10. So 10 is my answer. Okay. Now we're going to do some examples together in the guided practice. I'm going to pause for the calls. These are the notes for today. And we're going to work on some guided practice problems. So now we're going to do our guided practice problems, okay? So let's look at this. Now, yesterday, we estimated each of these. We estimated to the nearest whole number. You see that? We did this part. Now we're going to be simplifying, okay? So simplifying is like reducing these into radical form. So now we're going to be writing answers in radical form, and then I'll show you how to write it as a decimal. Remember, think of simplifying a radical as like you're reducing a fraction, okay? You're going to leave it in radical form. You're just making it smaller, okay? You're reducing it like you would a fraction. All right, so this is how this works for 15. Let's do this together. We're going to rewrite the square root of 15, and we're going to draw a factor tree, just as we wrote in our steps and directions. Draw a factor tree and circle the prime numbers. So we think, what two numbers, and remember you cannot use 1, what two numbers can be multiplied to give us 15? Anybody? Very good, 3 and 5. So we're going to put 3 times 5 here. Great job. Okay. Now we look at 3. What two numbers other than 1 will give us 3? There is no other number that we can use other than 1 and 3. So we circle this. This is prime. It only has 2 factors, 1 in itself. So it's already broken down. Can't break it down anymore. 5. We think, what two numbers can be multiplied to give us 5 without using 1? And we don't have 1 because 5 is also prime. It only has 2 factors, 1 and itself, 5. So circle it. Any questions about how we drew the prime factorization for this problem? All right. So now we move to step 2. Step 2 is to rewrite all of the prime numbers, which are the numbers that are circled, under the radical sign. So we have 3 times 5, just like we did in our example. We write it in order from least to greatest. Then finally, number 3, not finally, the third step is to look for your pairs. We don't have any pairs here, so we can't take anything out. So when we multiply this back together, we realize that this is simplified. It was already as low as it can go. So your answer is the square root of 15. It was already reduced. This answer is written in radical form. Any questions about that? To write the decimal form of the answer, you can use your calculator. Okay, so when you use your calculator to write the decimal form for the answer, you press the second button and go down to x squared, and you get square root, and you type in the number 15 and press enter. And that gives you, look at this, 3.87. Let's round to the nearest tenth place. So that's about 3.9. So we're going to do about 3.9. And this is the decimal form of the answer. So you got a radical form of the answer, and you got a decimal form of the answer. Just like sometimes you can write an answer as a reduced fraction, and sometimes you can divide and write the answer as a decimal. Okay. Questions, comments, or concerns? Raise your hand if I'm moving too fast. Okay. Let's look at the square root of 50. Let's rewrite square root of 50 and use the same process to reduce or simplify this radical. We draw a factor tree. What two numbers can be multiplied to give you 50? Very good, babe. 5 and 10. So we got 5 times 10. What two numbers can be multiplied to give you 5 other than 1? Cannot use 1 in a factor tree. We don't have any other numbers, okay, other than 1 and 5. So this is a prime number. Encircle it. You can't break it down anymore. What about 10? Very good. 2 and 5. Good job. We know 2 is prime because it only has 2 factors, 1 in itself, and 5 is also prime because it only has 2 factors, 1 in itself. Any questions about the factor tree? Okay. So now we're going to take all of the prime numbers or the circled numbers and put them under the radical sign from least to greatest. The smallest number is 2, and we only have 1 2, times, we got 2 5s. 5 times 5. We're going to put all of the prime numbers under the radical. Next, we're going to look for pairs. We're going to look for numbers that repeat twice. Are there any pairs here? Yes. What pairs do we have? 5. Very good. So we're going to circle the pair of 5s. We only have one pair of 5s, so we take out 1 5. We only take out one number for each pair because this is square root. We don't have a pair for the 2, so leave it under the radical. Since that's the only number under the radical, is nothing to multiply here. This is the only number that we took out up from under the radical. So you don't have anything else to multiply it by. This is your answer. This answer is written in radical form, like a reduced fraction. Now we're going to write the decimal answer, okay? So to do the decimal answer, we type this in our calculator. Look at this. So we're going to type in the square root. So we press the x squared button, type in 50, and enter. Okay, you see 7.07. Let's round it to the nearest tenth place. That's one space behind the decimal. So that's going to be 7 point what? 1. Very good. So this is about 7.1 because remember we were rounding. And this is our decimal answer. Okay? That's the answer written as a decimal. Any questions so far? Okay. Let's look at 105 now. We're going to simplify 105. Let's rewrite it. 105. Okay. Now we're going to draw a factor tree. What two numbers can be multiplied to give me 105? Think about it. Well, the last number here is a 5. So we have to think it's divisible by 5. If you remember your divisibility rules, your dividing rules, what goes into a number rules, from probably 5th and 6th grade. If a number ends in 5 or 0, it's divisible by 5. So let's see, what number can we multiply times 5 to give us 105? So all you got to do is work backwards and divide. 105 divided by 5. Very good. It's 21. So we have 5 here times 21. Okay? Now, 5 is a prime number, just like we discovered up here, so we circle it. 21 is composite, and I didn't give you a definition for composite, but that means that number has more than 2 factors. Okay? So we can break down 21. What two numbers can be multiplied to give us 21? Very good. 3 and 7. 3 times 7. Okay? Both 3 and 7 are prime numbers because they only have two factors. Okay? The next step is to rewrite all of your prime numbers under the radical sign in order from least to greatest. So your smallest number is 3. Mark it out so I don't write it again. Your next to smallest number is 5. And then you have 7. Okay? Now you're going to look for pairs. Do you have any pairs there? No, you don't have any pairs. So when I multiply these numbers back out, I get what I started with because it was already reduced. We did another one that was already reduced. It just happens that way. It don't always happen that way, but it's just both of these answers were already reduced. This is the radical form. The decimal form for this answer. Okay? We're going to type it into the calculator again, okay? So we do the square root second x squared, and we type in 105, and we press enter. And look at what that gives us. That gives us 10.24 and some change. Well, let's round it to the nearest tenths place. That's one space behind the decimal. So that's going to be what? 10.2. Very good. So it's going to be about, because remember we rounded, 10.2. And the symbol for about, before I forget to tell you, the symbol for about is 2 squiggly lines. So sometimes instead of seeing about, you might see 2 squiggly lines in front of it because that's the symbol for about. Okay? All right, so now I want to see if you can do 130, the square root of 130 on your own. See if you can simplify it. You're going to copy down 130, and you're going to draw a factor tree and do the same thing that we did here. Okay? All right, I'm going to pause to give you time to do that. Well, actually, we're almost out of time. So I need for you to go ahead and finish working these, and then we'll make sure that you have the right or correct answers tomorrow, okay? So finish these on your own. You only have 3 to do. Do 170 here, draw your factor tree, and 32 here. Make sure you draw your factor trees, okay? All right, I'm going to go ahead and stop my video here. Please make sure that if you need to watch the video, you can go back and rewind and watch. If you have questions, feel free to text me, okay? Are there any questions before I stop? All right.